How are we doing, class? Today we're going to be going over amines, but you already know what we're going to do. What we do at the beginning of every lesson, have a go at these retrieval questions. Make sure you're answering in full sentences, okay? A primary amide has the nitrogen atom attached to carbon 1 on the carbonyl, okay? Aromatic compounds contain a benzene ring. Aliphatic compounds contain carbon atoms joined in straight chains or branched chains. So why are we learning about amines at the moment? On the left hand side I've got 1,5-diaminopentane and a picture to go with it, and on the right hand side I've got serotonin. Try and think, what possible links do we have to the last lesson with the picture on the left, and what possible career can you go into and using the picture on the right there? Well, last lesson we did look at some amines, and 1,5-diaminopentane is actually the scent that's given off from rotten fish. So when you smell something fishy, you know that that's 1,5-diaminopentane. And on the right hand side, serotonin is actually very important in the regulation of your tiredness. There's actually a condition where you don't have enough serotonin in your body and you feel sad and depressed. A possible career you can go into is pharmacology, where people have problems with their serotonin receptors and that affects them psychologically. These are the specification references that we're going to go through in this lesson. Make sure you've got them to hand and you can tick them off as we go through the lesson, okay? Alright, so let's first wrap our heads around what aliphatic and aromatic means. We kind of went through it a little bit in the starter retrieval questions, but I've got the definition, the actual root for them. Aliphatic comes from the Greek word for fat, and aromatic comes from the Greek word for spice. Here is a triglyceride, and it's one of the major components in fats. And also, aromatic, it's got that benzene ring. And this spice is called cinnamaldehyde. Sounds a little bit weird, but I think you already know what we find in this particular compound. So amines. These are organic compounds derived from ammonium with one or more hydrogens replaced with something. So on the left hand side here, I've got what we call an aliphatic amine. And of course, you can probably guess what's on the right hand side. It's an aromatic amine. So aliphatic, we're adding a chain. Aromatic, we're adding a ring. And remember, it essentially starts off as nitrogen with 3 hydrogens attached to it, ammonia, but we've removed one or more hydrogen and replaced it with either an aliphatic chain or an aromatic ring. Try and name these 2 amines. Well, the one on the left hand side, we've got a methyl group, so it's methylamine. And the substituent on the right hand side will be the aromatic ring, so it's a phenyl, so it's phenylamine. We also need to be able to classify the different amines that we have. We can either have a primary, secondary, or a tertiary amine. See if you can match up which one here is representing the primary, the secondary, and the tertiary amine. In the primary amine, only one of the hydrogen has been replaced. So that's a primary amine. We've got 1 R group there. In the secondary amine, 2 of the hydrogens have been replaced. So we've got 2 R groups on there. And tertiary, of course, 3 R groups, tertiary, 3. So 3 hydrogens have been replaced there. Whenever you need to understand which one is primary, secondary amine, or tertiary amine, just count the number of alkyl or aryl groups that you've got. So primary only has 1, primary is 1 first, secondary has 2, that's 2 R groups, and tertiary has 3, that's 3 R groups. Alright, let's see how we actually identify the different types of amines just from the formula. Remember that primary amines have one of the hydrogens missing, secondary amines have two hydrogens missing, and tertiary amines have all three hydrogens missing. Try and match these up. The primary amine is going to be the one that's NH2, and so that's the one on the right hand side. So one of those hydrogens from the ammonia molecule was missing. And if we look at that, it's C6H5NO2. So it's a primary amine. Don't get confused and think that the H2 means that it's secondary. Remember, we're looking at the replacements, the R groups. So that means that the secondary amine will only have one H, okay? So that's the one on the left-hand side. And therefore, the tertiary amine has no H's next to it. Well, technically, it does have a H next to it because of the C6H5, but you already know that's a phenyl group. And just to summarize all of this, primary amines, you'll see a NH2, secondary amines, you'll see a NH, and tertiary amines, you just see N. Alright, so I've got some alkyl amines here. Try and name these two alkyl amines. I should have also added that these are primary amines as well, but you can see from the structures, on the left hand side, the display structure, we can see N with two H's, and on the skeletal structure, you see the H2 there to let you know it's still a primary amine. The one on the left hand side, we have two carbons, so that's an ethyl, so that's ethyl amine. And if we count the number of kinks, 1, 2, 3, that's a propyl, so that's propyl amine. Pretty straightforward. It gets a little bit complicated if the primary amine group is not on C1. So when the primary amine is not on the first carbon, we use the prefix amino instead. Have a go at these primary amines now. So before we just put the alkyl name and then amine, or we'll put the arom name and we'll put amine. But since this isn't on position 1 normal, we have to designate what carbon the amino group is on. And if we have a look at the one on the left hand side, the full chain, longest carbon chain, we've got 1, 2, 3, 4. So that's a butane. And the amine group, but we're using a prefix amino, the amino group is on the second carbon. So that is 2-amino butane. And on the right hand side, we can see the functional group there is carboxylic acid. And it's 2 carbons, so that's ethanoic acid. And position 1 obviously will be that carbonyl carbon. And the amino is attached to the second carbon. So that's 2-amino ethanoic acid. Okay, have a look at this structure now and have a go at these challenge questions. So what type of amine is this? It's NH, so 2 of its H's have been missing, so that's a secondary amine. And it seems a little bit trickier to name this, and that's because we've got 2 alkyl groups attached to equivalent, in this case, equivalent alkyl groups, a methyl group on the left and on the right. The mega challenge says use CO2 to help you suggest a name for this compound. So let's think. CO2 is carbon dioxide. We have 2 methyl groups, so dimethyl. You already know what this should be. It should be dimethylamine. So let's summarize some of this. When you have the same alkyl group, you can just use the prefix di, tri, all of that, okay? This is only when you have the same alkyl group. We don't have to complicate the name. So in this instance, when we write it as a formula, you see that we've got that methyl group in brackets and 2 on outside of the brackets, so we've got 2 lots of it. And we can see it's NH, so that's a secondary amine, dimethylamine. Okie dokie, here I've got 2 new molecules, and I would like you to name and classify the amines, okay? Name and classify them. Alright, the one on the left hand side, we have no hydrogens, so it's a tertiary amine. All 3 hydrogens have been replaced. And when we look at this, with each of the alkyl groups, each 3 alkyl groups are methyl groups. So they're all equivalent. And there's 3 of them, so trimethylamine. The one on the right hand side, we've got a hydrogen there. So only 2 hydrogens have been replaced, so that's a secondary amine. And when we look at the 2 substituents, they have 2 kinks, 1, 2, so that's ethyl. There's 2 of them, diethylamine. Alright, so I've got this molecule now. It's an interesting molecule. Have a go at these challenge questions. So what type of amine is this? We've got 1 hydrogen, so there's 2 substituent, that is a secondary amine. More challenge, why can't we use di-tri prefix for this? Well, on the left hand side, the R group is methyl, and on the right hand side, 1, 2, 3 is propyl. We've got 2 different alkyl groups attached to it, so we can't use di-tri prefixes for this. Now it says suggest 3 things that the name of this compound should contain. 3 things. We see 3 different things here. First of all, we have that amine is a secondary amine, but we don't have to worry about that yet. So we need amine in the name somewhere. And as I said, on the left hand side, we've got a methyl group. On the right hand side, we've got a propyl group. So we need methyl, propyl, and amine. So how then do we go about naming this? When the groups are different, you have an N-substituted derivative of the larger group. What does that mean? That means we look at the larger carbon chain, and that will stand as the base name. And then the smaller chain will be the N-substituted derivative, okay? So let's look at how we should name this. The largest group, carbon chain, is propyl, so we've got a propylamine. And it's N-substituted with a methyl, so that's N-methylpropylamine. And if we were to write that, that would look like this. We've got the methyl group. I'm trying to keep the colors consistent. We've got the methyl group in green. We've got the amine group in red. And we've got the 1, 2, 3, the propyl group in black. Again, the longest carbon chain there is the propyl chain. So it's a propylamine. So it's an N-substituted propylamine, and that substituent is methyl, so N-methylpropylamine. So I've got 3 things I'd like you to do with this one now. I'd like you to first draw the skeletal structure for this, classify what type of amine it is, and then name the amine as well. Okay, so we see that the N has no hydrogens associated with it, so it's a tertiary amine. And attached to it, we've got a methyl group on the left hand side, we've got an ethyl group that is branched off, and we've got a propyl group on the right hand side. So let's look at what that will look like. Something like this. We've got that ethyl group, the methyl group, and then the propyl group. As I said, it's a tertiary amine, and the longest chain is the propyl. So we've got N-substituted propylamine, but we've got 2 N-substituents for each of the hydrogens that isn't attached to the longest chain of carbons. And we put it in alphabetical order. So we've got N-ethyl, N-methyl propylamine. Going through that again, we've got a tertiary amine because there's no hydrogens attached to the nitrogen. We look at the longest carbon chain, that's a propyl, so it's a propyl amine. And other chains are N substituted, and we put them in alphabetical order, so N, ethyl, N, methyl, propyl, amine. Alright, amines can act as bases. That's due to their lone pair, so amines can accept protons and they behave like bases. So we've got an amine here, which is actually, if you have a look on the left hand side, that's an ethyl group, so that's ethyl amine, which is a primary amine because we've got those two hydrogens there. It's just one substituent. We add the hydrogen, and then by dative bond we get this. And notice that this is an ion because there's one more proton than the electrons that are accounted for there. And this ion, how we name this now, we started off with ethyl amine, but now it's kind of looks back like it's an ammonium ion again because we've got that NH3 plus, so it's an ammonium ion, so we call it ethyl ammonium ion. Keep that name in the back of your mind, and let's look at how salts are formed here. So propyl amine reacts with hydrochloric acid to form a salt. Write a balanced equation and name the salt. So think about the last activity we did. Propyl amine reacts with hydrochloric acid to form a salt. Write a balanced equation and name the salt. Alright, we've got the propyl group, 3 carbons, and then the amine group attached to it with HCl for hydrochloric acid. And we now have the propyl group with the amine group that's had added a hydrogen to it. But because now it's positively charged, the negatively charged chloride ion is also now attached to it. So remember that before, since this is NH3, it's an ammonium ion. But it's got that propyl group attached to it, so it's propyl ammonium chloride. Because it's an ammonium, it's a propyl ammonium ion, but the chloride is now traveling along with it, so it's a propyl ammonium chloride. Have a go at this one now. Ethyl amine reacts with sulfuric acid to form a salt. Write a balanced equation and name the salt. Not gonna lie, this one would have been a little bit confusing because if you remember, sulfate ions are 2 negative ions and our ammonium salt is only a +1 ion. So we're going to need 2 lots of our amine. So 2 lots of the ethyl amine reacting with 1 mole of our sulfuric acid. That'll give us 2 lots of the ethyl ammonium ion because we need 2 positives to balance out the 2 negatives of the sulfate ion, okay? And sulfate ions make a sulfate, so we've got ethyl ammonium sulfate. I've got these 2 molecules now. Have a go at these challenge questions. So what's the name of this haloalkane? We've got a chloride attached to the first carbon and it's a propane. So that's 1 chloropropane. When these 2 react, what does the ammonium behave as? The ammonium here is going to behave, because it has that lone pair, is going to behave like a nucleophile. Explain why the haloalkane allows this reaction to occur. And if you think back from previous lessons that we did, it's because of that halogen is electronegative. That chlorine is electronegative, so it's going to move the electrons closer to itself. You form a slightly positive carbon atom because the electronegative chlorine moves the electron away. So now that ammonia can act as a nucleophile and attack the molecule. And this is part of a 2-stage process of getting an amine from a haloalkane. You're going to need to know this, okay? The first step, we add ammonia. and that makes a salt, and then we add sodium hydroxide to get the amine. And as I said, it's a two-stage process. What I'd like you to do now, can you write the balanced equation for these two reactions? So we start off with 1 chloropropane and it reacts with ammonia. And then that product from the first reaction reacts with sodium hydroxide. See if you can work this out. So there's that first reaction. We can see that we've got 1, 2, 3 carbon, so that's 1 chloropropane reacting with ammonia, and that gives us our ammonium ion, which is ammonium chloride, but it's propyl ammonium chloride. And now that propyl ammonium chloride is going to react with sodium hydroxide, and this is what that forms. It's going to give us the amine, and we can see 2 H's there, so that's a primary amine, so that's propyl amine. It also gives us sodium chloride and water. Now have a look at this activity. We've got these 2 molecules, and I'd like you to have a go at these challenge questions. Well, the top one, that is propyl amine, and the bottom one is 1 chloropropane. Can a reaction occur between these two? And that's yes. And asking why? We already saw is because of that lone pair on the nitrogen will act as a nucleophile. It still has that lone pair there. So now let's look at what happens when propyl amine, because remember it's got that lone pair there, so it can still react with the haloalkane. Think about the salt that will be formed there, and then we're going to react it with sodium hydroxide again to make a new amine. So have a go, try and work out what this reaction would look like. So we've got the 1 chloropropane reacting with the propyl amine to make this molecule here. Notice that now there's only NH, so it's a secondary amine, okay? Because we've got those 2 substituents there. And when we react that with the sodium hydroxide, that gives us this. We still form the sodium chloride and water, but now look, we've got a secondary amine. And to name these 2 products, the first one, we've got 2 propyl groups, so that's dipropyl, and it's an ammonium chloride, so that's dipropyl ammonium chloride. Pretty straightforward. And we still have that dipropyl, but now it's an amine, so that's dipropyl amine. You can also form a tertiary amine as well, and that would look something like this, and that will obviously be tripropyl amine. So let's look at how we prepare aromatic amines. Phenylamine can be made from nitrobenzene. First, try and draw both of these molecules. So that's what nitrobenzene looks like, that's what phenylamine looks like. First thing you have to do is reflux with tin and hydrochloric acid and react with excess sodium hydroxide. And both tin and hydrochloric acid both act as reducing agents. Within this reaction, phenylammonium chloride is also produced. And you can see the phenyl group with the ammonium, and then that's the plus ion and the negative chloride ion, phenylammonium chloride. Okay, that brings us to the end of the lesson. Tick off what you can do, what you can't do, go back in the video and relive all of that again. So I'll catch you guys next week with the next lesson, alright? Peace.